Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be working on the old Apple II again. This is an original Apple II from 1978. It is not an Apple II Plus. It even has the original Apple II ROMs in here, so when you first power it up, it doesn't even boot into Basic. I made a couple videos last year on repairing this machine, and I'll link to those down below if you haven't seen them already. But at this point, this machine works perfectly, except for one thing. The keyboard that you see in here is actually a 2 Plus keyboard as one of my spares, and the original keyboard for this machine, which is this one right here, and it has this larger power button thing. It's not a button, it's just a light that looks like a button. This is an original Datanetics keyboard for the Apple II, and when this keyboard is inside that computer, this keyboard shows absolutely no signs of life. When I figured out this keyboard wasn't working, I just immediately removed it and switched over to my spare 2 Plus keyboard so I could get those videos finished. So now it's time to actually do some proper troubleshooting on this keyboard, because there are some circuits and stuff on here, to see what's wrong, see if I can get it fixed, and then return this computer back to its original 1977 or 1978 Apple II glory. So without further ado, let's get right to it. Doesn't this machine just look absolutely amazing? I mean, the only thing that lets it down is the fact that this keyboard is not the right one, and it has this flush power light here, which actually the word power is even rubbed off on it. So I think this original keyboard, once it's fixed, it's gonna look a lot better in here than this one does. But yeah, the machine, it looks amazing with this beautiful AMDEC 300A monitor, which absolutely complements the look of this machine. Like with the brown color of the badge, the keyboard, and the monitor bezel here, it's not a perfect match, but it looks really good. And the beige color of this monitor, which isn't particularly yellowed, and these do yellow quite a lot, absolutely matches the color of the Apple II exactly. You have to think that they made this monitor with the Apple II in mind. Incidentally, you can see I have the game Droll by Broderbund loaded up on the Apple II right now, and it's a great 48K game, which works perfectly on this machine. And I was pleased to find out when I turned this computer on after having not used it for several months that it absolutely just fired right up and worked. All of that Deoxit in those sockets that I put in here did the trick, and this thing is still 100% functional. I was half expecting it to not work, like have some bad chip contacts again, but that was absolutely not the case. There was one additional failure that happened after I powered it up to start playing around with it again before actually turning on the camera here. And after running it for several hours, I was actually playing this game and it just froze. Ran the Apple Confidential Test Disk, which is for the original Apple II and I think the II Plus. And sure enough, it reported that there was another bad RAM chip in here. And this is another one of these NEC 4116 RAM chips. I had already replaced 3 of these on this motherboard, and sure enough, a 4th one has died. So I just swapped that out because the program was really nice and just told me which chip was bad, and the computer has been working perfectly ever since. I even left it on again, running this game demo here for several hours, and there were no issues. Okay, enough talking. Let's get to fixing this keyboard. I gotta take the computer apart to do that though, because you need to be able to plug this into the motherboard, and it has a short little cable here, so this whole top cover needs to come off. So we're gonna have a jump cut. Oh, actually, look, the computer is not fully apart yet, but that's because there's something else I want to talk about before I completely do take it apart, and is that the top cover here that you have on the machine was not properly attached before when I was first started working on this computer. There are little plastic hook and loop type things, you know, Velcro is trademarked, so I don't know what they're actually called, but they are in the corners here that hold this top cover down. And the adhesive that sticks it down to the bottom part of the case, this part, was no longer effective anymore. So they both had come off and they were just stuck to the top lid, so I could pull them apart and then I had both pieces. I wasn't actually sure how to re-adhere it to the top cover, but as you can see, it is actually connected now, and if I pop it off, it's a really firm connection there, as you can hear. It's because this part of the fastener is now firmly attached to the bottom cover on the machine. And what did I use to adhere it together? I used this 2-part epoxy JB weld, and it has worked really well. I gave it 24 hours to cure, and well, what can I say? It seems to be stuck on really, really firmly. All right, we're all ready for some keyboard troubleshooting. The motherboard's out here on the bench. I have a different power supply because I left the other one in the bottom case. Got the little 9-inch Apple IIc monitor. Let's turn this on, make sure everything still works. The power switch is over here. Yep, there it is. We are at the flashing machine language monitor prompt. That is completely normal for the way this Apple II motherboard works with these original ROMs in here. Okay, as a quick refresher, on the Apple II motherboards, the Apple II and the Apple II Plus, the keyboard connects to this IC socket right here. The keyboards used on these computers basically take the keyboard matrix, which you see right here, and this is the Apple II Plus keyboard. And if we flip this over, there's a little PCB here that has this large 40-pin dip. And that's an ASCII keyboard encoder. So it takes the key press that you're pushing and actually converts that into an ASCII signal. It's just an 8-bit ASCII parallel signal that's sent across this wire here that is picked up right on the data bus by the CPU. Now, it's really easy to tell these Apple II Plus type keyboards. One of the things that gives it away is the fact that the power light here, this is a little light bulb under there, is under this plastic cover, and it does not look like one of the other keys. As I mentioned earlier, on the original Apple II keyboard, it actually looks like a key, and it actually is installed into what looks like a key switch, although it doesn't actually move. And I think what was happening is that people thought that this was actually a power switch that they could push on, so Apple changed it to this lower flush mount design on the newer keyboards. But they also changed to this design where the encoder was its own PCB, and they probably did that because they could source multiple keyboards from different manufacturers, and as long as the connection there that goes between the keyboard matrix and this encoder board was the same across the manufacturers, Apple could just make this PCB, stick it on there, and they knew it would work properly with their Apple II Plus or Apple II machines. But the main difference with this keyboard and the Apple II Plus keyboards is that the keyboard encoder is actually right here. It's this 40-pin dip, and there are other ICs right on the main keyboard PCB. So we flip this over, you can see the keyboard PCB here with all the switches soldered onto it, and then there are the ICs, and the keyboard encoder is underneath that piece of foam there. I'm not 100% sure why Apple went from this design to that two-board design, but it's probably to do with that second source of manufacturers once they started really ramping up production of Apple II computers. Given the fact that I had an Apple II Plus keyboard plugged into the Apple II means that, of course, the pinout and the signaling and everything that comes over this ribbon cable is exactly the same between an Apple II and an Apple II Plus. In fact, the reality is an Apple II Plus is just an Apple II like this one with upgraded ROMs. It's pretty much the only difference. Well, the keyboard is different, the motherboard has the upgraded ROMs, and then it has that different badge on the case that says Plus. And I think they changed the model number as well. I'd have to imagine that a lot of the original Apple II ROMs like this machine has are lost because people simply went to the Apple dealer and they had their machines upgraded to a 2 Plus, where Apple just swapped out. I'm not sure they swapped out all the ROMs, so they swapped out some of these ROMs and they populated these 2 extra ROM sockets here so that you turn on the computer, it would not only auto boot, but it also would go into Applesoft Basic. And what I mean by Applesoft Basic is that square bracket prompt that you get when you turn on an Apple II. That's Applesoft Basic. The original Basic, which was called Integer Basic, was one that Woz wrote and was actually a lot more compact than Applesoft Basic, and it fit within this smaller amount of ROM space, hence the fact that there were these 2 empty ROMs. I think there were actually extensions you could buy to put in these ROM sockets called the Programmer's Aid, which when you added them in actually extended the functionality of Basic by adding some graphics routines that weren't originally built into the Integer Basic. Okay, I'm back to the keyboard. So when I tried this last time, what happened when I plugged it in is I think the power light didn't even come on consistently, and if I move this wire around, it was sort of a bad connection there. None of the keys worked except for reset. That would actually reset the computer, but the reset signal is actually just a separate signal that comes through the wire here. It is not part of that ASCII keyboard signaling that comes from this controller IC. Now, what I suspect might be the problem is due to the fact that this connection was flaky due to this bad ribbon cable, that this keyboard encoder chip, which is a very old part and actually requires bias voltages to work properly. It's not just a 5-volt part. I think this has a negative voltage rail, and it also takes possibly 12 volts as well. And if those signals aren't getting through this ribbon cable properly due to the bad connection, it is possible that an IC can be damaged by not having the right bias voltage. 4116 DRAM, like is found on the original Apple II, is very similar in that it requires not just plus 5 volts, but also plus 12 and minus 5 volts. The plus 12 and the minus 5 are also bias voltages, which, just like this IC, they need. And it's quite possible, well, so I hear at least, that these DRAM chips can get damaged if those bias voltages are not there. Now, I've never actually tested that because I feel bad purposefully damaging a 4116 DRAM chip. They're just not the most common things anymore. So I suppose it is possible that this IC got damaged. Now, there are other ICs on the board here. Looks like there's a couple TTLs there. I don't know, maybe a 555 timer. And under the space bar here, and you can't really see it there, but there is another IC there as well. So it could just be that one of those is bad. I don't exactly know what those do. There's no schematic available for this keyboard, at least that I'm aware of. But what we do have, luckily, is the actual data sheet for the keyboard encoder IC right here. So with this, I'm hoping that I can at least probe around on that IC to figure out if it's still good or not. Now, initially, it was my thought that that keyboard IC was bad, although, you know, like I said, I haven't done any troubleshooting. And I was a bit despondent about that because, like, look at this keyboard. It's in really good shape. And if that chip were bad, well, where exactly are you going to get a replacement of those? Now, you might be thinking, since I have a data sheet for this encoder chip, that it's just an off-the-shelf part, and we could just stick another one in there. We could find a new old stock one of those. Out of the box, the chip is programmed to send specific ASCII codes for specific matrix inputs. The thing is, every keyboard is going to be a little bit different, so it's a mask programmable ROM device, which means at the factory or potentially when Apple manufactured the keyboard or whoever manufactured this keyboard for them, programmed these ICs on their production line, stuck them in the board so that they have the appropriate programming to send the right ASCII codes based on what key is pushed. If we stuck an off-the-shelf part in here, you might be where you push the G key and you get the number 1, because the way the keyboard matrix is wired is completely up to the designer of the keyboard. It has nothing to do with the keyboard encoder IC. So what all that means is that an off-the-shelf part won't work unless there was a way to program it and we knew how to program it, or it was already programmed for this keyboard, which is not likely that any of those are around unless it was taken off another one of these keyboards. Now, luckily, there's actually a solution. If this chip is bad, we are not lost. And the solution is inside this box right here. This little package was sent in by Joe over at Joe's Computer Museum. He's got a YouTube channel where he reverse engineers all sorts of Apple related stuff. And what he has gone and done is reverse engineer this particular IC on this keyboard and has created a replacement. It's a little PCB that plugs right into your keyboard. It's got like a CPLD or something on there, and it replicates the functionality of this chip and will bring this keyboard back to life. Now, before I go sticking this chip into this keyboard, we're gonna have to do some rudimentary troubleshooting first, just to make sure that, you know, we're seeing the signals from the matrix getting to this IC, but it's not sending out the data that should be going to the motherboard, and then we'll know for sure that that chip is bad. But I have to say, Joe assures me that that chip is a pretty common failure on this particular keyboard, which is why he went ahead and created a replacement. I'll just add that in addition to this replacement IC, he's got other keyboard encoder replacements as well. In fact, I asked him if he could reverse engineer the one on the Macintosh Plus and the 128 and the 512 keyboard, because those ICs go bad as well. They don't generally fail on their own, but they go bad if you use the wrong keyboard cable, because Apple switched around the wiring on the keyboard cable from a normal phone handset cord. And if you use the wrong one, it will damage that chip and render your keyboard completely inoperable. So I don't know if he's gone ahead and made one of those replacements yet, but if he does, then that means a whole bunch of keyboards out there that have been killed by the wrong cord will be able to be revived by replacing the encoder with one of his new modern replacements. Okay, so let's begin the troubleshooting. First thing I need to do is connect this thing up to the motherboard again. So looking at this ribbon cable that goes to the keyboard, it doesn't look like there's anything wrong with it. In fact, it seems to have gold pins, so that's a little surprising that it has bad contact. But maybe it's this particular socket on the motherboard. These sockets are absolutely flaky. The thing is, the Apple II Plus keyboard does work, and I think I have tried the cable from the Apple II Plus keyboard in this motherboard with this keyboard, and it actually didn't work. With this hooked up though, let's see if we're seeing the same problem where the power light doesn't come on reliably unless I kind of fiddle with these connections. Incidentally, if you're not sure how to connect this ribbon cable up to the IC socket, pin 1, which is where this red stripe is on the wire, faces towards the notch on all the other ICs, so that is over to my right. when you're looking at this connection on the keyboard, which also can come off, if you have it flipped around the wrong way, the wire will go that way, and that is not the way it goes. It does go this way, and the cable's a little bit crimped because when this keyboard is screwed into the top cover, it pushes down on the cord. In addition to that though, the red stripe, which is towards pin 1, also is towards pin 1 on this IC, which is right there. The notch is facing towards me. Alrighty, let's power this thing up. Okay, so we are actually getting, right there, the power light. So that is working. Let's fiddle with these connections a little bit, see if that kind of comes and goes. It doesn't. That seems to work. Maybe the Deoxit that I had put in here at some point did the trick. But pushing keys on the keyboard, as you can see on the little monitor there, we're getting absolutely nothing whatsoever, except for reset, which actually will reset the machine. On later machines, you actually had to push Control and reset, and Apple did that so you didn't accidentally hit reset while you're in the middle of a game or whatever. Like if you went to push the return key and your finger slipped, whoops, you hit reset and you reset the machine. But on this original Apple II keyboard, you just push reset and that does reset the machine. So yeah, this thing, it's acting completely dead, just as it was before. All right, let's take a look at the data sheet first for this keyboard matrix so I can kind of understand the way this keyboard works. So here's the pinout on this IC. There are X lines there, there are Y lines there. Those are going to be driving the keyboard matrix so it can sense which key is actually pressed. And it looks like there is a set of B pins here, which are going to be, I think, data output pins. Looking at the block diagram, we have a clock generator that's just going to be on board. I noticed there's a 555 timer here, which is probably, I think, generating the clock, or maybe it comes from the motherboard, to be honest. We have the Y pins here, which are going to be part of the keyboard matrix. So there'll be an X and a Y set of pins. So key sense logic. And over here, yep, there are the X drivers. So I think what it does is it pulses the X lines and it senses on the Y lines. And that makes up the rows and the columns. It also directly looks at the shift keys, and there's a lock IO, which I think is for a caps lock, which is not used on this keyboard because it doesn't have any capability of lowercase, even though I'm pretty sure this chip on here does. What happens is that X and Y information comes into the IC here, and this is read-only memory. So this is that map memory that maps the keyboard pushes to particular ASCII characters. And then that comes out of here on these data bits, and it goes through one character store. So I guess it can store one particular character. And then that drives it down to the motherboard through these data lines here, which I think are the B lines. But in addition to that, there are some keyboard strobe lines, which are basically what tell the logic on the motherboard that the keyboard is ready to send a character to the motherboard. And you know what I just realized? The light's not on anymore. The computer's still powered up. Let me just check these connections here. So that is definitely there, and so is that. And it's not working. I wonder if like the light burned out or if this really has a bad connection. If I push the reset key, we'll get nothing. So I'm telling you, this wire here, I think it's pretty faulty. Now, because of this faulty cable, what I went ahead and did is I made a new cable here. And here it is. I basically found some of these little connectors that you have to crimp onto a ribbon cable in my parts bin. And I had to like stack some sockets on, and I used my vise to then go ahead and make a new cable. So since this cable definitely seems dodgy, we're gonna connect up this new ribbon cable to the keyboard here. First time I'm doing it. Let's see if this makes the light work a little bit more reliably and the reset button work again. All right, looks good. I'm just double checking. So the red wire is towards my right, which is the same as the notches on these ICs, and the same for this ribbon cable. The red wire is towards me, same as the notch on the controller. So if we power this up, aha, we have the power light again. So it's not burned out. And we hit reset, and it is working. Pushing the keys though, we still have nothing. Okay, so yeah, pretty sure that this wire is bad, and I don't really know why, but it is. So there's that. But the replacement cable is just as good, and I made it a little bit longer as well, so there's a little extra length available. All right, so back to the block diagram. If we probe the data strobe outputs, not to mention these data driver lines when we push keys on the keyboard, well, we should see activity. Not to mention, I should be able to look here at the X drivers, these X outputs, and we should see active strobing going on. If we're not seeing any activity on those pins, well, maybe something else is wrong, like the clock generator signal is not getting to the IC, so I suppose we should check that as well. So the oscilloscope is up. I have the probe ready to go, and let's see where pin 1 is. Here it is. Now I was about to try to probe that pin, and there's like a piece of tape over the IC here, which is making it really difficult to probe. It was sort of covering the pins on the lower edge for whatever reason. How long has that tape been on there? Don't know. Okay, power up the computer again. So on the oscilloscope here, you can ignore the noisy thing. That's because I'm grounding off the video circuit. It's far away from the keyboard. Okay, so we have a good clock signal, which is running at, oh, it's hard to see here. Let's move this over. It's running at 63 kilohertz or so. Is that right? I don't know, but I'm assuming it's right. The signal looks fine. All right, next up, we're gonna go to pin 12. All of these pins here, well, actually we could start up here on pin 4 because that's the X9. Those are the outputs to the strobes and the Ys are the input. Alrighty, so we are not really seeing anything on that first pin. If I push keys on the keyboard, we're not really getting anything. Let's check these other pins. These and the other X pins basically look like nothing's happening whatsoever. So I'm assuming that this chip, even if it just has power and it's working, it should be outputting those strobe signals out of the X lines. They're not strobes, whatever, the scanning of the matrix. The scanning of the matrix. It's like a Keanu Reeves movie. It's not doing anything at all. Now we can check these B lines. These are the outputs that come out of the chip if we just want to be sure. So it starts at pin 40. That particular pin B4 is stuck high. Now B3 is over here on pin 1. I assume that's just going to be stuck high as well. Yeah, nothing is happening whatsoever. So I'm really gonna have to go right to the fact that this keyboard encoder chip is not working. It's not hot at all, but I think maybe losing those bias voltages from that bad cable maybe killed it. So let's pull this chip out of here. Alrighty, here's the little package. I just opened it up. It looks like in this bag here is the IC plus a couple 3D printed goodies. We have JCM for Joe's Computer Museum, his logo there. Plus, yeah, what state is Joe in? I'm sorry, I don't recognize the state, but this is a little 3D printed heart in his state. It's very common in Oregon here to see these on people's cars and stuff, a little Oregon state with a heart inside, but I think that's not unique to this state. Those are kind of all over the place. Well, at least not in California where I live there, but in every other state. JCM-1.com, hashtag Museum Joe, JCM. 8 bits are all you need. That's Joe's slogan there. It's pretty awesome. And here's his other thing, Z80, 6502, 6809, and a good old Intel 8080. 8 bits are all you need. So here it is. This is it. This is his IC. So it's this little tiny, super low profile PCB. If we pop this off, there it is right there. And I can't quite read the part number on there, but it looks like it's a microchip part, so I'm assuming that's a PIC microprocessor, which makes sense to me because, you know, that keyboard matrix should be possible with a PIC. And on the top side, there it is, the MM5740 replacement. Freaking awesome. And Joe sent along a little packing slip, Apple II forever. He's an absolute fan of the Apple II. Thank you very much, Joe, for sending this in to the channel. And I think Joe told me that he's affected by the parts shortage, so I think he has these in stock again. But if he doesn't, just email him if you need one of these, and he'll be able to let you know when he can get you one of these. Alrighty, so let's pop this in. I'm gonna use my goggles just to make sure that I have it aligned perfectly in this socket here. Give it a good push, and it goes down in there really nice and firmly, and it's in there really well, and it's super low profile, which is good because I think there is not a lot of clearance in this one spot right here. This little bar here is actually what screws onto the bottom of the Apple II motherboard, and I just don't know how much room is there. So I think the fact that this is incredibly flush is a good thing. And he does have a notch right there printed on the silk screen, so I know that I have it in the right way. I guess we're ready. Turn this thing on. Hope it works. So there it is. Push the G key. There it is. We have a freaking working keyboard. So what I need to do is test to see if all the keys work, because I've never actually done that. And then, well, these old mechanical type keyboards can easily get corroded and dirty, especially because they're old, even though this one is so clean. So let's see what doesn't work on here. Good number of keys aren't working. So we have 2 and 4 on the top row. Then the next row we have return, EW, and escape. Now the thing is, EW and escape are all over here on the side of the keyboard, which is weirdly close to 2 and 4. So it's quite possible that those are on the same matrix as these other keys, or on the same row as these other keys, because on the next row down, the control key doesn't work, as does the S key. So it's a little unusual that control S, 2 and 4, and escape and W and E are all not working. It's a little cluster of keys right together. So it does sort of scream that it might not be a problem with the key switch, it might be a problem with the rows. We'll be able to check that in a second using the multimeter. But additional keys that don't work, yeah, the return key is not working over on this side of the keyboard. Then, well, I don't know for sure the control's not working, but I'm pretty sure it does not work. The S key, like I said, the H key appears to not be working, and same with the colon, and also the arrow keys don't work. But return, arrows, and colon, those are all very close to each other, so that's a little suspect. On the bottom row, the V key is not working, which is this, and it's in that cluster where it could also be related to that same row or column or whatever that's not working. So we'll just need to check that those traces are good. There could be bad solder joints or bad traces on the backside that are causing that problem. Now the L key I have in a little box here because it works, but something's wrong with it. It's like really, really stuck down. None of the keys on this keyboard feel very good to type on, but this L key, something's the matter with it. And I noticed on the back side, look at what's going on under here. Something weird is happening, and that is the L key. So I'm wondering if some kind of damage happened at some point to this. And look, when I push L, it's sort of stuck. It does push. When I go like this, it's typing an L on the computer, but I don't know what's going on there. So I'm gonna power off the computer, and I'm gonna grab a key puller, and we're gonna pull this L off and just try to see what the heck is, wait, what? What is this? What is this? What the freaking heck is going on here? It looks like it broke or something. Let's pull off this key right next to it here and take a look at what a key switch on this keyboard should look like. Okay, so that is a good key switch right there. That, I can't even tell what's happening there. That may not be repairable, whatever's wrong here. I'm assuming the key switch broke and they wrapped a wire around the switch, and when you push it down, does that even come up on the camera? Yeah, I think it's showing up. When you push it down, it's making contact with the wire, and they melted a hole in the key switch. And when we look at the bottom here, that does appear to be the case. It looks like they have that wire soldered on both of the contacts there. Yeah, that's very unusual right there. I think what I'm gonna have to try to do is remove that key switch and try to figure out what exactly someone did to this at whatever point that they did that. And maybe I can, maybe that switch is not damaged and we can try to figure out what happened there. It's very, very funky. Okay, well, I got this out, and fortunately it's grim. As you can see, there are no longer any contacts coming out the bottom of this key switch. And indeed, it's exactly what I thought. They basically made a new contact with wire. And unfortunately, the whole key is really bindy and sticky, as you can see there. You know, it worked, but yeah, I don't know what else to say. Don't understand why this would have been the case. Maybe this switch really did fail, but I just don't really understand what happened to the internal guts of this. Maybe they didn't have any Deoxit that might have fixed this, or a sonic cleaner or whatever. But unfortunately, there's nothing left of this switch to try to recover. And that means I'm gonna have to try to somehow get these wires back through the holes in the board. I mean, what? I don't even know. I think I'm just gonna undo these wires altogether, and this is gonna be an inoperative switch. Now, I think what I'm gonna do is I'm gonna take the repeat key here, and I'm gonna use that switch in that position, because that one did work. And that way we'd have a working L key, because look, let's be honest, you can do without the repeat key. You can't do without the L key. So I'm gonna move that over there, And hopefully, it looks like the contacts on the board, the little the traces, are not damaged. So hopefully that switch is going to work in that position. And then I'm just going to take this switch here, remove the wires, and I'm just going to put that in the repeat position, and it's not going to work. It's just, you know, it's going to look normal. But yeah, that's just very unusual, I gotta say. All right, so the repeat key is out, and I did use the desoldering iron because this is a double-sided PCB. Unlike most keyboards, there's one screw that screws into the switch body, and I just took that out, obviously. And now let's try to reinsert this into this position. And I don't know if the keys are the same angle. I think they all are, so that should totally work if this is not too damaged. I am looking in there, though, and it looks like they drilled out the holes. So hopefully there is enough on here. I'm going to put some flux down there to make sure that the pin and the existing trace actually do make a connection there. Okay, let's power this on. There it is. So that's K and there's L. Okay, so L is working. Awesome. And it feels a whole lot better than that other one. Okay, repeat key is back on, and you know, it doesn't look, well, it wobbles a lot because the pins are missing that are soldered onto the board, but it doesn't look that off kilter like this L key. But the L key is on very, very firmly, and I don't really understand why it looks slightly off kilter. All right, you know what? I just reflowed the two pins on the L key, loosened that screw a little bit and tightened it, and now it looks a lot better. You could see by the reflection, it's slightly different. I think the fact that the two pins that were soldered in, those holes were drilled out, it's not in exact the right position as it should be. But to be honest, if you didn't know what you were looking for, you probably wouldn't notice. Now, the repeat key is floppy and moves around, but that's just the way it's gonna be, but doesn't work anyways, so it's not like you're pushing that key. Okay, so now I have to figure out what's wrong with the other keys that are on here, which we have the little cheat sheet of. Let's start with the 2 key. Let's see if there's actual continuity on the 2 key. And I'm gonna unplug this from the computer so we can flip this over and I can start probing around with the multimeter. First, what I need to do is just make sure that I'm getting like close to 0 ohms when I push the key. And if I am, then that kind of tells us that there's probably a problem with a trace somewhere. But actually, if we look at 2, which is this key right here, the trace goes right down to that key, which is W, which is also not working. And the W goes down to the key below it, which is S, and that's also not working. And then S goes down to what looks like X, and X is working. So I just need to kind of check continuity between these as well, and we'll just have to see what I can find out. Okay, so that's good continuity there. I'm gonna hold down the 2 key. Okay. 72 ohms, everyone. So that's just bad. If we go on the 1 key here, getting 0.03, but yep, that is a bad key switch right there. Let's check the S key underneath it. That one doesn't even register. Oh, that's the W key underneath it. That doesn't give us anything. That key appears completely dead. Let's check the control key, which is sort of hanging out on its own over here. That one is at 0.33 ohms, so that key, oh, that's the escape key, which I did put a question mark on. I didn't know if escape worked, but that's because with the Apple II, you gotta jump into basic and it's hard to even test the escape key. So yeah, I guess that key is actually good. Let me just update my sheet to say that that key is good. All right, well, I'm gonna go through this and I'm gonna check what's on my list here and what actually ohms out good, and then we will try to figure out a way to fix these bad key switches. All right, I have done some testing and found some interesting stuff. So on this note here, everything with a tick mark, so 2-4 return EW, those keys don't work. The escape key turns out that it does work. I guess I couldn't test it properly. Well, I mean, continuity tests correct on it, so it seems to work. The H key actually works. The right arrow key, which is right here, I've actually removed it, was stuck connected. Like it had 0 ohms or 0.2 ohms, even when I wasn't pushing it. The left arrow key, on the other hand, also didn't test with any continuity. L key actually works. and then the V key also doesn't work. So lots and lots of keys that don't work. They either have like 40 ohms, 60 ohms, or no continuity whatsoever. Now the arrow key that was stuck, I desoldered it, and this is it right here. And unfortunately, one of the pins fell out of it. But I'm gonna say, taking a look at that someone has had this out of the board and done something here, because one of the pins is very wobbly and the other one just sort of fell out and it looks very melted. I used my desoldering iron and it very quickly got out of this board. I did not do this damage to it by desoldering it. So I don't know. It doesn't look like someone has been inside this switch. So I need to try to open this, I guess, and try to figure out exactly what's happened here. Now, looking at these switches here, I don't think there's actually any way to open these. These look like they're kind of plastic welded or sonic welded together. So non-serviceable switches. That's really, really unfortunate, which kind of gives me not a lot of hope for this keyboard, to be honest. Even though it's, working now, we have a working keyboard encoder at least, so it's sending some key presses. But how exactly am I supposed to fix this key switch here, which, yeah, it looks like someone has massacred it and broken one of the pins out. I'm actually wondering if this being pushed down might have caused some of these other switches not to work, like the H key, for instance. And actually the traces, which you can't really see from the arrow key, make their way over to this part of the board here. So it's quite possible that it wasn't working because of that. So the only thing I can kind of think to do is take one of these keys, like the 2 key maybe, and put some Deoxit down that key switch and then just push it a whole bunch of times and hope that none of the other keys have been massacred with like, melted off like the arrow key was here. I kind of have to imagine that this keyboard was just really problematic on this computer, and whoever the previous owner was just tried their hardest to get these key switches working by opening it up and melting them and doing that whole crazy hack on the L key, which, worked. I mean, it was making contact, but that was not a good thing. Yeah, okay, so I'm just gonna quickly test all of these keys again, make sure the ones that don't work still don't work. I may drip some Deoxit down the key stem, take the cap off and drip it down. That sometimes fixes keys. It's not super reliable in the long term, but it can work. All right, it's the next day, and well, I've gone ahead and I've done a bunch of work on this keyboard. So I let the Deoxit sit overnight, just hoping that this would fix some of the key switches, but really it didn't. And what I did is I started reading up about these Datanetics key switches on here to see if really there was any way to fix these. Like maybe I was missing some little trick about opening them up, or perhaps people had already taken these and put them in the sonic cleaner and decided that that was a really good way to make these switches work properly again. Unfortunately, after doing quite a bit of reading on Apple II forums and also Desk Authority, turns out that these Datanetics key switches have a very fragile design with a very thin sort of plastic mylar type layer in them between 2 metal contacts. And well, unfortunately, even contact cleaner like Deoxit can potentially eat away at that plastic, but certainly alcohol like 99% IPA, if you put it in there, that could do it as well. And people theorize at least that putting these in the sonic cleaner also can damage that mylar, which probably, I think, leads to a short circuit on these switches, or it doesn't seem to help them at all. So really, long story short, turns out that if you have one of these keyboards and you have bad key switches, there's no way to fix them unless you, well, get replacement key switches that don't have a problem and you swap them out on your board. So in the morning when I tested this keyboard and I found that, well, the switches that I had put Deoxit into, they at least respond, but they often give multiple key presses, and the realization that there was no way to fix those without just finding replacement switches, I decided to rearrange the switches on this board, and I have this little handy chart here. So these switches here along the top here all have the repeating problem. So H, 4, W, Y, and well, the back arrow. Now the left arrow, of course, or the right arrow, I mean, this one was not working at all. That was the one that had those broken pins. that essentially rendered that entire key switch inoperative. The repeat switch also, we know that one doesn't work because I swapped out, I think, what was it, the H switch with the repeat key. So that's a dead switch as well. So I decided to take the switches that had problems and swap them with switches that are less used. So like the H key, which was actually a very problematic key. That one really, really doesn't work very well. I took that and I swapped it with the plus key. The 4 with the period, the W with the dash, the Y with the comma, the left arrow with the colon, and then the right arrow, which is inoperative entirely, I made that the left shift key. I figured 2 shift keys, one of them should work, and the other one, if it doesn't work, it's not the end of the world. You can still use the keyboard. So the 2 inoperative keys on this keyboard now are repeat and left shift. Once I made that swap, I went ahead and typed in all the keys again just to double check that, well, there wasn't any other double pushes, and it turned out that the Z key also was giving double pushes. So I went ahead and I swapped that with the question mark key. So Z should be good now. And unfortunately, I went through and typed in all the keys again, and I found that the V key was also not working very well. And there are no more modifier or like less or not important keys to swap that with, but the V key mostly works. It's occasional double pushes. A lot of the other key switches that are on here, like the dash, I think, and the plus, they're bad. Like you push that one time, you're gonna get like 3 or 4 of those. So that's pretty frustrating, but at least you can backspace now without having double pushes. That's the back arrow there. So counting up the number of switches that are either double pushing or not working very well or completely inoperative, that's at least 9 switches that this keyboard needs to, well, make it type a little bit better. What kind of sucks as well is I know the enter key was one that was problematic, and I put Deoxit down there, and at first it was doing double pushes. It seems to be working fine at the moment, but I kind of worry about any of the key switches that I put Deoxit in, that they're either going to stop working at some point in the future, or they'll at least revert back to the way they were. There were lots of reports of people with these Datanetics keyboards, which incidentally were also used on early Apple II Pluses, that said that if they type on them a whole bunch, the keys kind of start to come back to life, but then if they store the computer and they don't use it for a little while, those same keys start to go bad again. And people also reported the same thing about putting contact cleaner. They didn't say Deoxit specifically, but contact cleaner into the switches. Also, they would revert back to not working properly after a little bit of time. At least at this point, all the letters and all the numbers should be working properly, and the space in the enter key and the arrow keys. So that's most of what you needed if you tried to like type a basic program or something into this computer. But ultimately, typing on this keyboard, while it looks really nice, is not going to be a very nice experience. So there's really not much more I can do with this keyboard. So before I put it back in the computer, let's take a look at the encoder IC with the oscilloscope, just to take a look at what those rows and columns should look like and those data strobe lines on a working encoder. So let's start on the clock pin, just like we did the first time, and there's that same clock signal, obviously generated either by the computer or by something on this keyboard. Now, if we take a look at pin 1, which on the schematic here is B3, I'm not seeing anything right now. Let's push a key on here. Oh, look, it changed. So if I push keys on the keyboard, it sometimes triggers on it going low to high or high to low. So that's doing something, I don't know what exactly. But when you're not pushing a key, it's basically just sitting there doing nothing. Now, I'm on pin 4 now, which is the X9 line. So I think that's what, one of the columns or rows. Now, this is the output. So this is just strobing all the time. And when I push keys, I don't think necessarily that's going to change at all. So if that original controller were working, the X pins would have been outputting some type of a signal. It might not have looked exactly like this, but it should have been some kind of pulsating signal that would be then seen through the corresponding Y inputs when you push the right key that bridge the 2 connections together. So with the scope on auto triggering, I'm back on the Y pins. If I push the keys, oh, okay, so that key, any of the keys I push, there's a little bit of a signal, which must be some capacitance or coupling or whatever that's going on. But one of the keys, there it is, this one I'm pushing the H key, and now we're seeing a much more clear signal. If we zoom in a little bit, there it is right there. So when I push the G and the H key, it's both showing the same trigger on the Y input, but the controller can tell it apart because as it scans through all those X lines, it actually goes through them probably consecutively, one after another. The G key probably connects something like X1 to this particular Y line, and the H key is connecting X2 to this particular Y line. Now, I don't actually know what it's connecting because I don't have the matrix mapped out, but that's how this microcontroller can tell the difference between the G and H key, because the signal that it's seeing on that Y line It depends on which X line is being driven at that exact moment, so it can tell which key you're pushing on the keyboard. That's sort of the way the matrix works. I know I'm not doing a very good job explaining how the keyboard matrix works, but essentially when this controller is working, like the original one was not, we were not seeing any activity on the X or Y lines, which told us right away that that chip was not working properly, especially because it had the proper clock signal going into it, and yet it wasn't actually functional. Incidentally, and I didn't mention this earlier on, the chips that are on here, the other TTL logic chips, besides the 555 timer, I think there's like two 7404s, which is a hex inverter, and then there's a 7400, and that's just like a buffer chip. So there's not much logic going on here. I think it's just inverting some of the signals, probably because that's what the Apple II is looking for on the motherboard. And there we have it. The machine is all back together. Let's turn this on. There it is. It just drops right into the machine language monitor. I do have a floppy drive hooked up. Let's grab a disk here. It's a copy of Droll, the same game that I was running before. We go 6, Control P, and we hit enter. And there it is. The machine is working. I'll load that up. So I have kept all the bad parts that I took out of this thing. The 2 RIFAs are there, the bad RAM chips, plus the bad keyboard controller chip, and of course this bad cable. I will bag this all up and keep it with this machine because of course, even though those are bad parts, it's just a cool little part of history to know what bad parts were in here and what was needed to get this thing working again. If we exit out of that and we hit enter, the main keys are all working. Now, as I mentioned, there are some that print double characters, like, let's see, colon. All right, colon is working and not working. It's kind of not very reliable there. The dash key is working okay, slash and question mark. Well, that seems fine as well. Period. Okay, comma printed way more commas than it should have. And of course, this shift key here does not work. I know it's definitely not ideal. You still have non-working keys, but the main keys, oh, looks like the K typed in twice there. Keys, oh boy, S is not working very well either. Okay, so there are plenty of other switches that are bad on this thing. The main keys are working okay. All right, W did too, and S did too. Okay, so I said 9 switches were needed. This thing probably needs 15 or 16 switches for it to get this fully working. But let's be honest, no one is going to be typing long essays on this thing. You just need to be able to do stuff like press 6 and Control P to boot the floppy drive. That's the main thing if you want to, try to run some software and stuff on here. So that is going to be it for this keyboard repair video, and actually that's going to be it for this original Apple II. I'm going to be giving this thing back to my friend, but don't worry, there'll be plenty of other Apple II content on the channel. I have more cool Apple stuff to take a look at in the very near future. But I am kind of glad that this thing is finally fully operational after I did those repairs on the motherboard, well, the bad chips and stuff, and then finally I got the original keyboard working. Now, this keyboard repair wouldn't have been possible if it weren't for Joe over at Joe's Computer Museum, so a huge thanks to him for sending this chip over to me. I'll put a link in the description to his channel and, of course, his web store. So if you have one of these keyboards with the same chip in there that's dead, well, now you know how to figure out that it is dead, and now you know where to get a replacement to get it up and running. So if you liked this video, thumbs up. If you didn't, you know what to do. Hit that subscribe button if you haven't already. Huge thanks to my patrons. Their names are scrolling off the side of the screen. They really make a lot of this possible here in the basement. I couldn't do a lot of this without them. So thank you very much to them. And they get early access to videos and other cool behind the scenes stuff. So it has some benefits to being a patron. And yeah, I guess that is going to be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.